So right now we're going to try some quick problems talking about the surface area and volume for pyramids and cones. Let's first dissect the pyramid. Okay, so here's a basic picture of a pyramid. So the pyramid has a base on the bottom. It can be triangular, it can be rectangular, it can be a square, it can be a pentagon, it can be any shape at all, and then it comes up to this point on top. We are going to stick with simple, perfect looking pyramids that have a square base and where this vertex is perpendicular to this center. You drop that perpendicular, the height, and it's going to be in the center of that base. So let me take this picture. I'm going to pull it apart a little bit. Okay, so here's the pyramid. So your pyramid has this base. We are only going to do pyramids that have square bases. So this side is going to equal this side. So your base is equal to s squared, side squared. Not always. Again, I feel like I have to really stress that, only for the problems that we're going to do today. Aside from that, we have from the vertex, we are going to drop a perpendicular line that comes to the middle of that base. It's going to be perpendicular to this base, and that is called h. That's the height. So that's one measurement that we're going to have in a pyramid. The second measurement is going to be so let's look at the different sides of this pyramid. We already talked about the base, but the pyramid also has 1, 2, and in the back and on the left, 4 sides, and all of those sides are triangles. If you wanted to find the area of one of those triangles, well, triangle is base times height. This is the base. But that height inside the pyramid is not part of this side. It's not part of the face. So what we need to do is have another segment that comes from the vertex to the side, and that's going to come all the way down here like this, and it will be perpendicular, and that guy is called the slant height. And because the letter H is already taken, we are going to use L. It's just the most common abbreviation for slant height. So the measurements that we are going to have are going to be the side of the base, remember it's going to be the same all the way around, the height on the inside, and the slant height that comes from the vertex to the middle of one of the sides down here. Okay. So with that, we're going to look at this little guy. Okay. So now, just going to straighten that. So you see that you have your base, and of course there's the 4 sides of the base. The slant height is this guy here. Hopefully you can see that slant height. And then right here on the inside in the middle with that perpendicular, that is your height. Here are the formulas that we're going to be using. First one is going to be the surface area formula. So the surface area formula is, oh, and by the way, for these guys, I always stick to the formulas. Surface area is 1/2 capital P. When you see a capital letter in the formula, it's because it's already another formula that's being used inside. So P is for the perimeter of the base. That's for the perimeter of your base times L, which is your slant height. So 1/2 times the perimeter of the base times the slant height. Add that to capital B is the area of the base. Now we're not going to write a formula in here in case the base is a different shape, but we said our bases are going to be squares. So we are going to use side squared. Every time that we do our problems, we're only doing squares. Moving on. Volume. So volume, look, a pyramid comes to a point, right? So when the cone came to a point last week, we said it's going to be 1/3. So B is going to be that area of the base. Fill it with your height times 1/3 when it comes to a point. Let's try an example. So we try an example here, and I'm going to do this guy. Okay. So, surface area. Surface area, remember, that was 1/2 times the perimeter times your slant height plus the area of your base, capital B. So 1/2, 1/2 times your perimeter. Well, here's our example here, and it's 5, 5, 5, 5. So all of our sides are 5. That's a square. Notice this 9 here. That's a slant height. So it's 1/2 times your perimeter, which is 20, times the slant height, which is 9, plus capital B is the area of the base, and that's 5 times 5, 25. Plug that in the calculator, 115. It is area, so feet squared. Fine. Now we're going to check out what the volume is. So the volume is 1/3 times the area of the base, so it's 1/3, times 5, which is 25, times the height. So 1/3, 25. The height we don't have. That's this guy in here. I get it. You're looking at it. But let's see how we can actually get the number. So when you look at this, if it's hard for you to see, imagine this is actually like a pyramid or something that you could stand outside and see. And we're going to stand over here on the right side, and we're going to pretend we are looking through it like it's glass. And if you're standing here looking through, then it looks like it's a triangle at the bottom. Okay, so sideways would look like this. There's your triangle. This is this 9. Across the bottom is this, and that's 5. But your height came down the middle, and that's your h, and that's what we want to find. We have a right triangle. We actually have 2 right triangles, but that's what we're going to use for our Pythagorean theorem. So 5 is this entire base. Cut it in half. 2.5 on this side, 2.5 on that side. So now for this triangle here that you see, side squared plus side squared, so a squared plus b squared equals c squared. So I wrote that down over here. Plug in for a squared. B squared is my h, I just left it as b squared, times 9 squared. So 81 minus 2.5 squared, take the square root, 8.65. Plug that in the formula for height. Multiply this in the calculator, and it's 72.1. Remember, for volume, it's cubic units. One more example that we can go through together is going to be this guy over here. So let's see. I'll start with my formula. So I'm going to rewrite my formula, more or less. So the surface area is 1/2. Great. Perimeter, well, that's 96 times 1, 2, 3, 4 sides, right? So it's the perimeter, so 96 times 4 times my slant height. That I do not have. I have the 20 on the inside. Okay, so since I have that 20 on the inside and I don't have, oops, let's do this. I have the 20 on the inside and I don't have the other. I'm going to picture looking from the right. So this was kind of a wider triangle. 96 was my bottom. When we dropped this perpendicular, we said that was 20. Well, 96 cut in half is 48. And you can kind of see I squeezed a 48 in there. But you are going to be looking for that slant height. Here's your triangle. You are going to do a squared plus b squared is equal to c squared. Add these together, take the square root, and L is equal to 52. So I'm going to plug 52 in here. So 1/2, 96 times 4, 52, plus side squared because it's your base squared, and that's where I get this 96, 96, 96 squared. Figure it all out, and that's 19,200 yards squared. For your volume, hey, because they gave you what this height was, the volume is quick and easy. So it's 1/3 times the area of your base, which is 96 times 96, 96 squared, times your height, which is 20. Plug it in the calculator, 61,440 yards cubed. Okay, cones. So we did cones, at least partially, last week. We looked at the volume of a cone. So maybe I'll actually do the volume first, since we kind of already saw it. Our volume. Again, it's a cone. It comes to a point, so that's your 1/3. Area of the base. Remember, your base is a circle anyway. Pi r squared times the height. I didn't draw the height in here, so let's do that. From this vertex, we are going to drop that perpendicular down right to the middle. That is your height. So in a cone, there is a height in the middle. That's a radius for that circle, which is the base. And again, L is the slant height. So that's that slanted part of the cone. Fine. So circle, which is pi r squared, times your height times 1/3. That's your volume. For surface area, well, for a surface area of a cone, there are two pieces. And one of the pieces, so the one surface for the cone is that base on the bottom, and that's your pi r squared. But then there's this formula. If you ever had an ice cream cone that had that paper wrapper on it, and you peeled the wrapper off, it would open into some kind of V fan-like shape. And to find the area of that, it's pi times the radius times this slant height. So we are just going to use these formulas and plug in all the numbers accordingly. Let's go with number 3. Number 3, first we want the surface area. So here's my picture, and I'm rewriting my formula. I'm coming down here. So when I rewrite my formula, pi RL plus pi r squared. Great. So pi times my radius, which is 3, slant height, oh, here it is at 8. I just put it on the other side, 8, plus pi times r squared. 3 squared is 9. 24 and 9 is 33 pi inches squared. Perfect. Moving on to volume. What we do not have for volume is this height number. I get it. You see the 7.4 because I wrote it in. We have to find that. So it's 1/3, fine, pi r squared, so pi r squared is 9, times your height. Hopefully you see here, I'm going to outline it in red. Again, you see a right triangle, and your right triangle has 3 for one side, and maybe we'll even call it h for this other side, and your hypotenuse is 8. So it's going to be 3 squared plus h squared is equal to 8 squared. 64 minus 9, take the square root, and h is equal to, there it is, 7.4. So once you find that, plug it into your formula, multiply out everything, maybe except the pi, and then you put the pi in your final answer. This guy over here, just to kind of quickly go through one more, rewrite your surface area formula, pi r L pi r squared, pi times your radius, which is 10, times the slant height. Slant height we don't have. They gave us the height, the h, is 24, not the slant height. Well, when I look at this triangle, my two sides are 10 and 24, and you can do 10 squared plus 24 squared is equal to c squared if you want to go ahead and do that. But I already noticed that this is a 5, 12, 13 multiple of 2, so 13 times 2 is 26. So I'm going to write that in. So I know 26 is my slant height. Pi times radius squared, that's 100. There's your 360 pi. You can write that in up here. And then the volume, 1/3 base is your circle, pi r squared, so pi times 100, times your height, which is 24. 800 pi kilometers cubed. You know what? I'm going to keep the same video going. I'm going to go to the back. What's on the back? Spheres. Straight up, use your formula for sphere. Don't stray from it. 4 pi r squared. All you need to know for a sphere is what the radius is. So just use your formulas, plug and chug. So let's look at number 13. In number 13, they give you 5. So just using your formula, 4 pi r squared. Well, r squared is 25, if that's 5, times 4 is 100. And stick on the pi. Then we have over here 4/3 r cubed. So my r cubed is 125 times 4, and that's 500, divided by 3, and then keep pi. Never multiply out the pi, just makes it messier. There we go. So plug and chug, use your formulas. When the assessment comes, have these formulas ready. So all you have to do is very carefully plug into the formula.